Well, hello everybody. Thank you so much for joining us for another Sky Tonight astronomy talk with the Fleet Science Center and the amazing Dr. Lisa Will, the Fleet's resident astronomer, who normally reigns supreme over the Dome Theater in our beautiful building, which is unfortunately still closed and will remain closed, it seems, until the beginning of the year. But that doesn't mean that science closes or stops. It just means we bring it virtually to you, but we still are sad that we're not going to see your faces at the Fleet Science Center in the Dome Theater for weeks to come. But we appreciate you being here, still being interested in science, still supporting the Fleet Science Center. We very much thank you for that. We're very grateful. And we look forward to engaging you further in science. All right. With that said, a quick preview of the next month's talks. So for October, we have comets and meteor showers, I think, or is that November? What did I just have in my presentation?
Life cycles of stars next month.
That's right, life cycles of stars. And then in November is the comets and meteor showers, and in December is galaxies.
Sounds right, yeah.
Perfect, yay. So those are upcoming Sky Tonight talks. They're already on our website, rhfleet.org. You could just search for Sky Tonight there, and you can already purchase your tickets if you would like to all those upcoming 3 events. And of course, we have more science talks, so please visit the Fleet website and stay up to date with us on social media so that we can tell you about all the amazing science talks we have coming up. That was a shameless self-plug and necessary and hopefully appreciated self-plug. And now I'm going to turn it over to Lisa, who's going to give us a presentation about the sky tonight. When you look up tonight, what constellations can you expect to see? What stars, what planets can you expect to see? And then we're going to take a look at observatories around the world. We're going to do the Q&A at the end of her presentation, but if you have a question already, use the Q&A function and shoot us the question anytime you want. Just this way you don't forget your question, and we will try our best to get all the question answered at the end. All right, with that, dear Lisa, take it away.
Thank you very much, Andrea. Like Andrea said, I'm Dr. Lisa Will. I'm a professor of physics and astronomy at San Diego City College, and I'm the resident astronomer at the Fleet Science Center. Welcome to the Sky Tonight. The Sky Tonight is a show that we do the first Wednesday night of every month, where we give you a tour of what's up in the night sky. And then we talk about a different topic every month. And so you've heard some of the topics that are coming up. And tonight we're going to talk about some ground-based observatories. I tend to focus on the space-based observatories a lot because, you know, reasons. But we do want to talk to you a little bit about some important ground-based observatories, especially ones in Southern California. There are some historically important ones in Southern California that I think you might like to be aware of. So before we start doing a sky tour, let me share my screen and we will talk about some current astronomical events in the news. All right. So this is the Earth. Now you might notice what you're seeing is the line between night and day, what we call the terminator, going across the face of the Earth. And you notice it's straight up and down. It goes north-south. And that can only happen on 2 days of the year, on the autumn equinox and the spring equinox. This year, the autumn equinox is on September 22nd, and that's the time when the sun crosses what we call the celestial equator, and it marks the beginning of autumn here in the northern hemisphere. Equinox is a term that stands for equal night, which means that the hours of daylight are approximately equal on the equinoxes, and it's the only time of year where the sun rises due east and sets due west, and that's on both equinoxes. So September 22nd is the autumn equinox this year. This is a bit of information that was just released today from LIGO, which is the Laser Interferometry Gravitational Wave Observatory. And it is that there are two stations of it here in the United States, and then it works with the Virgo Gravitational Wave Observatory in Europe to try to detect gravitational waves being emitted by celestial objects. And so today it was announced that there was a merger of two gravitational waves, and it was detected. You'll see that GW190521, that means May 21st, 2019, gravitational wave observation. And what you'll notice is that it looks like that we detected on that day two black holes, one a little bit more than 60 times the mass of the sun and one a little bit more than 80 times the mass of the sun. And they merged and formed a black hole that's about 140 times the mass of our sun. And it's up there in the range called intermediate mass black holes. Why is this of interest to us? Well, intermediate mass black holes have actually never been detected with gravitational waves before, and they're this weird sort of interstitial sized black hole where the ones below that mass are black holes that can be made from the death of a single high mass star. Ones above intermediate mass size, well, we call those supermassive black holes, and we find those in the centers of galaxies. But this intermediate mass black hole range had yet to be observed with gravitational waves, and so this was an exciting new discovery. Press release was just earlier today. Oh, I wanted to show you this because there's a dust devil back there. But it's not one here on Earth. This is a set of images from NASA's Mars Curiosity rover. And one of the interesting things about having had rovers on the surface of Mars uh, over the years is that we've actually been able to observe weather. And one of the most common forms of weather on Mars is actually dust devils. And so here is a dust devil on Mars in early August of this year. And it was located about a third to a half mile away from the Curiosity rover. Some of you might remember we were still hoping to hear from Mars Opportunity, the Opportunity rover, the one that got whose solar panels got covered up with dust during a Mars-wide dust storm. Well, one of the reasons why we were hoping it might spring back to life was the Spirit and Opportunity rovers had noticed dust devils before, and the wind from them can actually scrape the dust off of the solar panels. And so, believe it or not, dust devils on Mars have had quite the cleansing effect for some of our rovers. But here's a dust devil on Mars as seen from Mars Curiosity. And then this is a set of images from the OSIRIS-REx spacecraft mission, which is currently in orbit around a very small asteroid called Bennu. And this is a set of images from a rehearsal maneuver where the spacecraft uh, extended an arm to get very close to the surface of the asteroid itself, because in October, we're actually going to collect samples of this asteroid using this spacecraft. And in a few years down the road, that spacecraft is going to return those samples back to the Earth. And so this set of images was taken in August 11th as the spacecraft was getting closer and closer to Bennu's surface in the area that it's going to actually pick up some samples. And so those are some astronomy events that have been occurring in the news. Now let's give you a tour of tonight's sky. So let's get you oriented here with what you see on the screen. You'll notice we have the cardinal directions on here. And so south is towards the bottom of the screen, north is the top of the screen, east is to the left of the screen, west is to the right of the screen, and directly overhead is pretty much in the center of your screen. So this would be what the sky would look like if you go outside tonight at around 8:30 if the weather is cooperating where you are. And so
I like
let's take
communicating.
communicating. I know. Well, let's see if I can communicate at some point this evening. All right. So I'm going to start off here with a tour of the signs of the zodiac, starting, and then we'll have to explain what the signs of the zodiac are. So over in the west around 8:30 tonight, the constellation Virgo will be setting. Virgo is the second largest of the 88 modern constellations that astronomers use. Its brightest star is named Spica, and it comes from a term that means ear of wheat because Virgo is typically depicted as a maiden or as a fertility symbol, and an ear of wheat ties in with the fertility motif. Spica is the 15th brightest star that we see in the nighttime sky, and it's located about 260 light years from our solar system. A light year is the distance that light travels in a year. So if you look up at a star that's 260 light years away, that means that the light that you see from it left it 260 years ago. So you're not seeing it as it is, but rather as it was 260 years ago. Now we're going to go from west to east across the sky, following the signs of the zodiac. And the next sign of the zodiac I want to talk about tonight is Libra, which represents the scales or balance. It is the only sign of the zodiac that does not depict a living creature, mythological or otherwise, and is fairly faint. From a metropolitan area like here in San Diego, Libra can be difficult to see. Its brightest star is named Zubin el-Ganubi, and that name comes from an Arabic term that means the southern claw. Now, scales or balance do not have claws, but the sign of the zodiac directly to the east of it does, which is Scorpius, the scorpion. And the fact that the southern claw of the scorpion is actually now in the constellation Libra just reminds us that constellation boundaries and which stars belong to which constellations have changed over time. And so in the modern boundaries for the constellations, Zubin el-Ganubi, the claw of the scorpion, is a star now that belongs to the constellation Libra. Now, Scorpius is probably my favorite sign of the zodiac because it looks like a scorpion. You got the torso, you got the little stinger at the end. And if you wanted to go take a look for Scorpius in the sky, you'll see here that it's fairly low on the southern horizon. So you wouldn't go outside and look up. You would go outside and look fairly level towards the south to look for Scorpius. And one of the things that you would see in Scorpius is the bright red star in its torso, which is Antares. Antares is an example of a red supergiant star. It's a star towards the end of its lifetime. Excuse me, and it's over 800 times the size of the sun. So if we were to put Antares in our solar system where our sun is, Mercury, Venus, Earth, Mars, the asteroid belt would all be inside of Antares. And so stars, as they go through their life cycles, which we'll talk about next month, they expand off their outer layers. And when that happens, they can get much bigger than they were in the normal or regular part of their life. So we will talk a little bit more about that next month. And then it is fairly bright in our sky, even though it's over 500 light years away from our solar system. The next sign of the zodiac over to the east is Ophiuchus, which you may not have heard of as being the sign of the zodiac, but it is for reasons we'll talk about later. There are 13 signs of the zodiac, and Ophiuchus is named the serpent bearer, which makes more sense if I put up the constellation serpents with it. So he's holding up a serpent in the sky. The brightest star in Ophiuchus is Rasalhague, located about 49 light years from our solar system. The next sign of the zodiac over to the east is Sagittarius, the archer, a centaur from Greek mythology, the half human, half horse. And when you go outside to look for it, though, you probably won't see a centaur. You'll see more what looks like a teapot in the sky. In fact, a lot of astronomers refer to Sagittarius as having a teapot shape to it, or we call it the teapot. And when you take a look at it, though, the way the arrow of the archer is pointing, so the parts that are sticking out pointing towards the west, you'll notice that those are intersecting with that fuzzy white haze going across the sky. That's the Milky Way. You will also notice that the Milky Way is at its brightest and at its widest down where the constellation Sagittarius is. And that's because when we are looking towards the constellation Sagittarius, down in that direction, we're looking towards the center of our Milky Way galaxy. So the Milky Way galaxy is a spiral galaxy. So it means that it has a spiral shape, but it's kind of flat like a pancake. And the stars in the Milky Way are kind of like chocolate chips in the chocolate chip pancake. So we are not, our solar system, we are not at the center of our galaxy, nor are we at the very edge of our galaxy. We're kind of halfway in between the center and the edge. And so when we're looking towards the center from our point of view, we're looking through more stuff, more chocolate chips on our way looking towards the center. And so it's brighter and wider over there. Our Milky Way galaxy is estimated to be about 100,000 light years across, and we are about 27,000 light years from the center. And so Sagittarius is pointing towards the center of our Milky Way galaxy. And if anyone ever asks you, hey, can you point to a black hole on the sky? I'd say look at where Sagittarius is pointing because it's pointing towards the supermassive black hole at the center of our galaxy. If you wanted to go outside and look for Sagittarius tonight, you'll see two bright dots in the sky. In fact, the brightest dot in the sky tonight, that isn't the moon, is Jupiter. Jupiter and Saturn are both over in Sagittarius tonight, so I thought we would talk about each of them for a few moments. This is a Hubble Space Telescope image of Jupiter. Jupiter is the largest planet in our solar system by far. It's over 300 times the mass of the Earth, over 11 times the radius of the Earth. And so it's so big that even though it's so much more massive than the Earth, it has a really low density, which means it's mostly a big ball of gas. And you can kind of tell that by looking at it here. What you're seeing here, the surface of Jupiter, is actually its cloud tops. Does Jupiter have a solid surface? Well, we wouldn't call it a surface. We'd call it a core, buried way, way, way deep down inside Jupiter. In fact, the Juno spacecraft that NASA sent to Jupiter, part of what it's trying to do is figure out how big the core of Jupiter is. Speaking of Juno, an astrophotographer named Kevin Gill did this beautiful rendering of some Juno data showing you the sort of the fluid motions in Jupiter's atmosphere. I could basically spend all evening long just showing you picture after picture of Jupiter's atmosphere. You really get that fluid motion like when you pour cream into tea or coffee and you stir it. It's that same sort of fluid motion that we're seeing there. So that's Jupiter, the brightest dot up in the sky tonight. And then this is Saturn. Saturn also up there to the east of Jupiter in the sky. This is a Hubble Space Telescope image of Saturn as well, most notable for its extended rings. You'll have to excuse me a moment. I'm kind of laughing because my dog is behind me, making very weird noises. Saturn is most noted for its rings, and to give you a sense of scale, Saturn is over 9 times the radius of the Earth. It has over 90 times the mass of the Earth, and its rings span the inner ring to the outer ring. I usually think of it as being about the distance between the Earth and our moon, and so that's quite a range of rings there. Now, I wanted to give you another way of looking at Saturn tonight. So what you're seeing here is Saturn, an image of Saturn from the Cassini spacecraft, where you're looking at Saturn through the haze of its largest moon, Titan. Titan has a thick extended atmosphere, and you're seeing its that orange tint here. And so that's Jupiter and Saturn up in the sky tonight. All right, so let's come back to the nighttime sky. So Jupiter and Saturn are in Sagittarius tonight. Now let's continue on our tour of the sky. And the next sign of the zodiac over to the east is Capricornus, the sea goat. It is the second faintest of the zodiac signs after Cancer, and the smallest in total area of all of the zodiac signs. In fact, only its brightest star, Deneb Algety, can be seen easily from a metropolitan area like San Diego. Sorry, my husband just had to come get my dog. I'm laughing. And so it's really difficult to go outside and see Capricornus without a dark sky in the available to you. But if you want to go try to take a look at it tonight, go outside and look to the east of Jupiter and Saturn. The next sign of the zodiac over to the east is Aquarius, which is the water carrier or the cup carrier. Despite both its prominent position on the zodiac and its large size, it doesn't have actually any particularly bright stars. Um, Aquarius has been associated with water for a long time. In ancient Egyptian astronomy, Aquarius was associated with the annual flood of the Nile. The banks of the Nile were said to flood when Aquarius put his jar into the river, overflowing it and thus beginning spring. If you want to go look for Aquarius tonight, even though it's a very faint, the way you would go look for it is go look for the moon rising over there in the east because the moon is in Aquarius tonight. So I just wanted to share the moon with you for a few moments. This is a full global map of the moon taken with the Lunar Reconnaissance Orbiter satellite. And so we're seeing the entire moon taken with the same camera to the same scale at the same level of reflectivity. So the same angle of sunlight coming in. As it's turning towards us right now, this is the near side of the moon, the side of the moon that you're used to seeing up at the sky. But because the moon is tidally locked with the Earth, what you don't see from the Earth is the far side of the moon, the side that is coming into view right now. And so even though the moon is our closest celestial neighbor, we didn't see the far side of the moon until the first spacecraft was put in orbit around the moon and took photos in the mid 20th century. So it just shows you that just because it might be close to us, it doesn't mean it's easy to observe. So you might have noticed that we talked about the signs of the zodiac and planets and the moon, and they were all doing sort of a west to east line across the sky. And so I've put a line in here that actually is the line that those constellations fall upon. Those are those signs of the zodiac. The reason why those constellations gained importance is because they fall along the ecliptic. If you look closely, you might notice that there are months of the year along that line, and that's because the ecliptic is the path of the sun. So it shows where the sun is on any given day of the year. So we are at the beginning of September, and we set the sky for about 8:30 tonight so that after the show, you can go outside and take a look at the sky. And so the sun is already set below the western horizon as we look at this. And so the ecliptic is the path of the sun across the sky, and the moon and the planets follow that same path as well. What it's really showing us is that our solar system is also kind of flat like a pancake, and the sun's path kind of dominates the plane of that pancake. So now let's go back real quick towards Sagittarius, and we're going to use Sagittarius to help direct us on the rest of our path across the sky because we said it was pointing towards the Milky Way, the center of the Milky Way. So let's follow the Milky Way north. And when you do that, the next bright star that comes into view is Altair in the constellation Aquila, the eagle. And as we keep going north, we'll come across another bird, Cygnus the swan, and its brightest star is Deneb at the tail of the swan. Now, Altair and Deneb look very similar in brightness to each other, although Altair is much, much closer to us than Deneb is. They're about 100 times different in distance. They're really different in distance from us. And so that's just a reminder that you don't have good depth perception on the sky. And then over here in the same part of the sky, we have another bright star, which is Vega in the constellation Lyra. Lyra is the harp of Orpheus from Greek mythology. And Vega and Altair and Deneb are so bright and so close to each other on the sky that it's easy to look for them as making a big triangle on the sky. And this big triangle is often referred to as the summer triangle because it's visible in the late evening over the summer and in the early evening here in the fall. So if you go outside tonight after the show and you have clear skies and you look straight up, it should be the summer triangle above you. Let's talk about a few more constellations of interest. We've got Bootes, the herdsman, and the name Bootes actually was first referenced by Homer in the Odyssey as a bit of astronomy that was used as a navigation tool, but it's not quite clear. There isn't really an agreement on who Bootes was supposed to represent from mythology, but that's how long ago that the mythological reference comes from. And its brightest star is named Arcturus, which means the guardian of the bear, because Bootes is up in the northern part of the sky, close to where Ursa Major and Ursa Minor are, although they're not easily visible in this graphic tonight. Another constellation of note is Hercules, a mythological hero from Greco-Roman mythology. It is the fifth largest of the 88 modern constellations, and its brightest star, Konophoros, is that comes from a Greek term that means club bearer, because Hercules runs around carrying a club. And what does he do with that club? Well, apparently he defeats dragons. Draco the dragon is up in the northern part of the sky, probably inspired by the dragon Ladon, who Hercules encountered during his adventures. The most famous star in the constellation Draco is Thuban, which was, you know how we have a North Star, Polaris, the North Star, up in the constellation Ursa Minor or the Little Dipper? Well, the direction that the Earth's axis points changes over thousands of years. And so, about 3,000 years ago, actually more like 5,000 years ago, the star Thuban would have been our North Star. And so we can actually see this by careful measurements of motions on the sky now and references in catalogs of stars. And then I wanted to point out a couple of constellations you may not have ever heard of before. We have Delphinus, which is a dolphin up in the sky, and it is an ancient constellation. And it was first cataloged by the Greek astronomer Ptolemy in the 2nd century, and it's thought to be one of Poseidon's dolphins. And then a more recent constellation is Lacerta, the lizard, up on the sky. It's a very faint, looks like just a little bit of wiggles up there, up on the sky, hiding. So there's a lizard hiding up in the sky near a dolphin, and also near a winged horse, Pegasus. If you want to go look for Pegasus up on the sky, you'll notice how there's that big square in Pegasus. We actually call it the Great Square. Astronomers refer to it as the Great Square in Pegasus. It's a big square up on the sky of bright stars. And so if you go out and look for it, they're not going to be as bright as the summer triangle. But if you go outside tonight and look to the east and you see a big square of stars, then you're looking at the constellation Pegasus.
Like a zoo up there.
I know, I know. And then we get to Cepheus, who represents a king from Greek mythology. And it is not a very bright constellation, but it is a astronomically important constellation because one of its stars, Delta Cephei, is the prototype of what we call a Cepheid variable star, which is one of the types of stars that we learned how their brightnesses vary to help us get at the first distances to galaxies, which was incredibly important. In fact, that sort of measurement was made by some of these ground-based observatories that we want to talk to you about now. So,
Lisa, before you
yes,
go to the observatories, we're going to take
uh-huh,
3 questions real quick because
of
they're
course,
related to just what you talked about.
of course.
First of all, how did the black holes collide? So that was at the beginning of your presentation.
All right, so in the case of black holes, these black holes would have formed when big stars ran through their fuel and ended their lives. And it's very common for stars to be in systems with more than one star. So if they were close enough to each other that they were gravitationally attracted to each other and their gravities pulled each other in. So that's how you would get black holes colliding. Good
Thank you.
question.
And then how do we calculate the mass of planets?
Ooh, that's a really good question. We do it now by our understanding of gravity. That the easiest way to calculate the mass of a planet is if it has moons going around it. And so I can measure how long it takes the moon to go around that planet and its distance from that planet, and I can use that to get the mass of a planet. It's actually much harder to get the mass of a planet that doesn't have moons. So you can estimate it from other things like its density, if you can get its chemical composition. But sometimes what really helps nowadays is for us to throw an artificial satellite or a spacecraft towards a planet, have it go into orbit, and then we can calibrate our knowledge of its gravity then too. But for example, Venus doesn't have a moon, but we could get an idea of its mass by looking at it and knowing it's probably made out of very similar stuff to the Earth, which it is, and then backwards estimating from its density. But it really helps if a planet has a moon.
And then last question before we move on to the observatories is how many constellations have been documented?
A lot, because there's no one real answer to that question. Astronomers use a catalog of constellations that includes 88 constellations, but that was agreed upon in the early 1900s by the International Astronomical Union. And they have a very, how shall I say this, northern hemisphere bias to it in terms of the mythologies that we pulled from over the years, because it's still the first set of catalog of constellations that professional astronomers started really using dates back to the 2nd century. And it was a Greek astronomer that put it together. But cultures all over the world have different stories that they tell about the sky, different constellations. So since astronomers don't just use constellations to share myths or cultural heritage, we use them for positions on the sky. We agreed upon 88 that we use. So professional astronomers use the same 88. But hopefully that clarifies that a bit.
Interesting. Thank you very much. And now we move on to the observatories.
All right. So, are there observatories? So, what I did was I actually used the same planetarium software, and there is an option to click on showing observatories, and everything you see there with a name are ground-based observatories. And so I just did this little clip primarily of ones here in the United States and hovering over the southwestern United States there. But I wanted to give you an idea that there are a lot of observatories all over the world. Some of them are large professional grade ones, and some of them are smaller ones. But I do want to talk about some of the more important ones tonight. What is this? Well, this is the size of the mirrors, and in some case lenses for the smaller ones of professional telescopes. And what you will notice if you look down at the bottom is that there is a tennis court and a basketball court at the same scale. So modern telescopes, oh, and there's a human. The human was so small, I didn't even notice it the first time. Okay, so modern telescopes are absolutely huge, and there's a reason for that. The larger the telescope, the better light gathering power. And so what I mean by that is astronomers often refer to telescopes as light buckets, and it's easier to capture light with a big bucket than a small bucket. And so with a wide opening than a small opening. So we need the larger is better so that we can capture light more easily from far away, distant, faint objects. And then the larger the telescope, the better resolving power it has. And if you have two telescopes that can work together in conjunction like your eyes do or your ears do, we call that interferometry. And you basically get the resolving power of a telescope that's that size. So if you think of your eyes as each being a telescope, you have the resolving power of a telescope that's the same as the width between your eyes. So it's kind of a weird idea, but you'll see interferometry in a couple of these tonight. So the goal with telescopes is the bigger, the better, and the better in space. But if we're going to be on the ground, we have to have large telescopes for us to get good resolving power and good light gathering power too. So the first sort of important telescope or observatory I wanted to show you is the Royal Observatory in Greenwich in London. And this is an image I took a few years ago where you kind of combine the old with the new. You have the observatory in the background that was established by King Charles II back in the 1600s. And then what you're seeing here in the foreground, that sort of gray metallic thing, is actually the dome above their planetarium. And so the combination of the old and the new there. Greenwich Observatory is now mostly functioning as a museum, with most but not all of its science operations moved further away from Greenwich, because Greenwich is in London proper, so it's fairly bright there. But what you might know this as being home to, it's home to the prime meridian, the 0 point of longitude on our globe, and it's also the home of Greenwich Mean Time, which we now refer to as universal time. So it's also kind of the 0 point of the time zones on Earth. So that is just one of the observatories around the world I wanted to mention tonight. Okay. Some of you who have attended our shows before know that I always say, don't let astronomers name anything ever. This is the Very Large Telescope in Chile. It's up on the top of Cerro Pedernal in the Atacama Desert in Chile. And so that's interesting because somebody just posted on here, why does Chile have so many telescopes? And this is a great example of why. So what you see off in the distance is that this is on a very high desert plateau. So it's up way high where the air is drier, so you're not getting interference from humidity, which is what makes the stars twinkle, by the way, up in the sky. It's humidity. It's annoying. Astronomers don't like water vapor in the sky. So the air is dry, so you get nice, crisp air. You'll also be fairly far away from any towns, and so the light pollution is not a factor here. And so typically that's what astronomers look for. We're looking for a dark site with low humidity that doesn't have human-caused light pollution. And I say human-caused because one of the big problems with light pollution that astronomers do have to deal with is just the moon itself. So when you apply for telescope time, you have to know, can you handle moonlight being up there? Will moonlight interfere, or can you actually do your observations with moonlight? So yeah, this is the Very Large Telescope, and also some other smaller telescopes with it that can work as an interferometer, like we were talking about with our eyes. There's also an extremely large telescope being built. Sorry, I just can't deal with the name sometimes. This is actually the
I
most
think they're very to the point. You know,
we're not clever. We're straightforward. The VLT, or the Very Large Telescope, is actually the most productive ground-based facility for astronomy, with only the Hubble Space Telescope actually producing more scientific papers based on its observations. Among the most important observations at the VLT has been the first direct imaging of a planet around another star, and tracking of stars moving around the supermassive black hole at the center of our own galaxy. This is a radio telescope that I bet many of you have seen images of before. This is Arecibo, a large, wide, it's 1,000 feet wide. Think of it that way. It's about 1,000 feet wide. And it's now the world's third largest radio telescope. For more than 50 years, from its completion in the 1960s till fairly recently, it was the largest. But now in China, there is one that is 500 meters across compared to this 300 meters. And so really, really large radio dish. And you might be wondering, why do we want them large? Remember, light gathering power and angular resolution. And also, the larger the wavelength of light you're observing, this is a radio telescope. So radio waves have longer wavelengths. You need a bigger dish in order to see things better. The sorts of research that gets done at Arecibo, one of the most important things they do actually is radar astronomy. And what I mean by that is that this just doesn't receive radio waves. It can also send out radio waves, and we use it to track asteroids and see which direction. So discovering asteroids and noting their motions, which is kind of important. But Arecibo has been having some hard times recently, and I wanted to point this out to you. It is dug into the mountains of Arecibo, Puerto Rico, and it's actually stationary in place. And we use the rotation of the Earth to actually point to where it is in the sky. And it has suffered damage from hurricanes recently, and earthquakes. And then this image is actually from August, where just one of the cables snapped. And the cable, they don't know why it snapped because it should have been good for another couple of decades. And so there is some wondering whether or not the abuse from recent hurricanes and earthquakes took its toll on the cables as well. You'll notice that I called this a mirror, right? But it's not flat and shiny like a mirror. Like now that you're underneath it, you can see up through it. Um, because radio waves are longer wavelengths than visible waves, you don't need your mirror to be as smooth in order to do detections. And so the smaller the wavelength of light, the smoother your mirror needs to be. So if any of you have ever had a satellite dish that you use to get TV, which is radio signals, those digital signals are radio signals, you've actually had a radio telescope dish in your yard. This is the Mauna Kea Observatory, which is on the top of the volcano Mauna Kea on the Big Island of Hawaii. And it is so high in altitude, it's about 14,000 feet in height, that it snows here. And that often surprises my students when I occasionally show them pictures of snow on this observatory. This observatory this is considered to be an international observatory because there are telescopes from space agencies and universities from all over the world on the summit of Mauna Kea. And there are currently 13 telescopes on the summit. This is a controversial site because construction that is ongoing on the summit of Mauna Kea was not done respectfully with the wishes of the native Hawaiians who consider this site to be sacred. So Mauna Kea has been in the news in recent years because of that. And so it is a site of active astronomy with researchers from all over the world using telescopes on this site, but we must be mindful and respectful of the people whose land that we use. This is a radio interferometer called the Very Large Array, right? Very Large Array. It is 28 telescopes, of which 27 are in use, and then one's always in maintenance as a backup. These telescopes are all on railroad tracks, so we can actually move them to make a longer or a bigger interferometer or smaller interferometer based on what they're observing. You may have seen this. Often gets used in movies because it's a very striking visual sight. It is located in New Mexico, not far from Socorro, New Mexico. This is an image on top of Mars Hill in Flagstaff, Arizona. This is Lowell Observatory. Lowell Observatory was established in the early 1900s by Percival Lowell. And it's one of my favorite places on the whole planet. It's got a wonderful visitors center. And what's culturally important about Lowell Observatory is that this is where Pluto was discovered by Clyde Tombaugh in 1930. And more impactfully, in the early 1900s, Vesto Slipher did the first measurements that showed galaxies should have redshifts, or that galaxies appear to be moving away from us. So the first bits of evidence that the universe started with a bang, the first evidence for the Big Bang were actually made here at Lowell Observatory in Flagstaff, Arizona. And then another observatory located in Arizona on the Tohono O'odham Nation is Kip Peak National Observatory, which once again, you have a bunch of telescopes up on the top of a mountain with dry air, fairly far away from lights. This actually isn't very far away from Tucson. I think it's only about 50 miles or so southwest of Tucson. But because Tucson has a bunch of observatories, professional observatories all around it, they've done a great job of mitigating their light pollution. So when I've done observing here at Kip Peak, the brightest light dome that I see in the sky is actually from Phoenix, which is a 2-hour drive away. And so you can actually work to protect light pollution to help observatories still see a dark sky. And so, yeah, you barely even know Tucson's close when you're up there. And so there are over 20 optical and 2 radio telescopes up on the summit of Kip Peak. And one of the uh, they're also known as one of the first places to do dedicated observations for what we call near Earth asteroids. And by near Earth, we mean, will that hit us sometime? So one of the places where they do large surveys of that. They also do great visitors programs where there is a telescope where I think about once a month you can actually stay overnight and to have somebody work through with you and take images on one of the smaller ones. You don't get the 4-meter telescope, but one of the smaller telescopes you can get time on. Now let's come to California. This is Lick Observatory on Mount Hamilton up near San Jose. This observatory is very close to one of the large wildfires going on right now. In fact, they were worried they were going to lose this observatory about a week ago. It's still there. It is owned and operated by the University of California system, and it has been around since the late 1800s. And it is so, and one of its major discoveries was kind of interesting to me. Galileo, back in 1610, discovered the 4 largest moons of Jupiter. The 5th one was discovered here at Lick Observatory in 1892. So big gap in the time it took between discovering those moons of Jupiter. I snagged this image from the Mount Wilson Observatory page because look at how gorgeous this is. So you are looking at Mount Wilson. This is an image that was taken this summer. Mount Wilson Observatory is located in the San Gabriel Mountains above Pasadena, California. So that sea of light off to the right is actually Los Angeles. And then over to the left, you might notice that a little fuzzy blob, you can see Comet Neowise. That was visible in the nighttime sky from here. So Mount Wilson is an observatory that's been around for over 100 years. And this is a Mack truck. Look, you can see the name Mack on it. This is an early Mack truck taking up the mirror for the large 100-inch telescope up to the mountaintop in 1917. So you're seeing it being driven up there. And when I came across this, I was just like, that is a literal Mack truck. And the 100-inch telescope depicted here is still in use. And that's one of the things about a lot of these ancient and old observatories. If they are built well, they can last a long time. And so this particular telescope, this 100-inch telescope, had been mothballed for a while in the 80s and 90s, but it's now back in use again. And you'll see that sort of wooden table in front of it. The original levers can still be used to actually move the telescope, although they don't use them anymore, but you can still use them to do that. And this is the telescope that was used by the astronomer Edwin Hubble, right? You've heard of Hubble. Edwin Hubble used this to determine that some of those fuzzy blobs in the sky we see are actually galaxies. So he used Cepheid variables to find the distances to galaxies. And then he combined that with Vesto Slipher's data from Lowell Observatory about galaxy redshifts and put that data together and discovered that the universe was expanding. And so those important observations that led us to the idea that the universe is expanding actually come from the southwestern United States, the first direct detections of them. And then a little bit closer to home, we have Palomar Observatory up on Mount Palomar here in San Diego County. It is owned and operated by Caltech, or the California Institute of Technologies, and it is home to 3 active research telescopes. And the research is done by astronomers all over the world, and this observatory has been around almost 100 years now. This is the 200-inch mirror being built at the time. This image comes from the mid-1940s, before the telescope was constructed. And at the time, it replaced the 100-inch telescope at Mount Wilson as the largest telescope in the world. And this was the largest telescope in the world up till the 1990s. This observatory still operates every clear night of the year, taking important data on supernovae, observations of exosolar planets, galaxies, observations of objects deep out in our own solar system. And so it's a really, really, really important telescope that we have here in San Diego County. And so hopefully I've convinced you that we have lots of really important and amazing work done being by these observatories all over the world. But I want to tell you one of the challenges that astronomers are currently facing. A report came out this week on the impact of satellite constellations on astronomy. And you might be wondering what a satellite constellation is. Well, in May of 2019, SpaceX launched the first batch of Starlink satellites. So they launched 60 satellites, the communication satellites, which are meant to help give broadband internet to people all over the world. However, astronomers didn't know this was going to happen. They had no clue that that I think it was the FCC, because they're communication satellites, no environmental impact report, right? No consideration of the sky as an environment, but just like, oh, sure, you can send up satellites. And so astronomers were surprised, and they are much brighter than I think anyone would have expected them to be on the sky. SpaceX is continuing to launch more and more of these. Amazon is planning on sending up a constellation of satellites, which makes them sound really beautiful. But um, no offense, they're just going to be awful for ground-based astronomy. So what you're seeing over there on the right, this is actually a set of images of the sky from one of the telescopes in Chile. So a professional class telescope in Chile. And all those streaks you see going across it are satellite trails going across from these Starlink satellites, because these satellites are incredibly bright. The result, or the final conclusion of this report, is that these mega constellations of satellites are going to alter not just astronomy for astronomers, not just the night sky for astronomers, but likely even to alter the appearance of the night sky for the casual observer. When we do on-campus classes, because at City College we're doing an online semester, I usually teach a nighttime astronomy lab, and from downtown San Diego, I could see streaks of these going across the sky during one of our lab nights. So Starlink, not necessarily a positive development for our appreciation of the nighttime sky, whether or not you are a professional astronomer or an astronomer like yourself who just wants to go look up at the nighttime sky. So
Faith in engineers that they'll figure it out for the next ones going up, that they're not so bright.
So they keep saying that. And a couple, they have launched, I believe, at least one prototype with the darker covering, and it doesn't seem to help much. Yeah.
Well, back to the drawing board.
Back to the drawing board there. Yes. All right, I see some questions.
Yes. Do you want to just take them yourself? Do you?
How about you do them, because that way you can clear them.
Okay, sounds good.
All
so
right.
there is some travel questions, so I'm going to lump them together, those two. You know,
Okay.
once we can safely travel again, what is the first or second observatory you would recommend? And then what observatories have the best visitor center and dome theater?
All right, so those are some interesting questions. So obviously here in San Diego County, you have Palomar, which does have a visitor center. So you're allowed to visit Palomar during the day. Never approach a professional observatory at night. They are locked up. I remember one night I was observing at Kip Peak, and somebody actually broke through the gate down at the bottom of the road, and you could actually see the light, the light from their headlights showed up in some of our images. You could actually, I mean, that's how dark it is there. So you got Palomar right nearby. So go there. If you're willing to travel a little bit further, Mount Wilson in LA does have a good visitor center. And I actually think Kip Peak does some really, really good programs. Now, none of them have a dome theater like we do here at the Fleet. That actually is not going to be, I mean, the visitor center at most professional observatories is there as an acknowledgement that we are using the land in that area, so we might as well provide education to the people who are nearby who want it. So it is done as an educational tool. It's not necessarily a money-making tool for the observatories themselves. Not that they don't charge, because they got to upkeep it somehow, but it really is more of a public outreach. But here in the southwestern United States, we have so many wonderful observatories to go visit. And like I said, Kip Peak does do some nighttime programs, and I believe Mount Wilson does too. So go to their websites. They all have websites that you can look at their visitors programs at.
Is there still astronomy work and research being done at Griffith Observatory or no?
Not so much. They do have astronomers on staff, but Griffith Observatory is up in the Hollywood Hills. For those of you who don't know, you have undoubtedly seen it in countless movies and films. It's that pretty dome looking out over LA. I don't know that they do any professional level work. They do bring out telescopes for people to use some evenings.
Thank you.
Yeah, because I've been there for that. It's been a while, but I've been there for
Yeah,
that.
I just remember they at least I think they had a dome theater when I went.
I think so.
Yeah, I
I
think
think
so.
so. But I
Not
think
as
of the
beautiful as ours. It's beautiful.
Yeah, so play nothing's good as the fleet, right?
I
But
think so.
observatories like Griffith and Greenwich, the Royal Observatory at Greenwich in England, because they now function mostly as museums, they have actually dedicated some of their space to things like dome theaters. Professional observatories don't have the dome theaters. That's just not where their focus is.
Yeah, and I know that some of the professional observatories you can't really go visit because I would like to go to Chile.
Yes.
And that's not something where you can just say, I'll travel there and visit.
No, because even if they do have a visitor center, it is incredibly difficult to actually get to some of the ones in Chile. Like they're a 10-hour bus ride from the closest town. So frequently when astronomers go to Chile, they go and they stay there for an extended period of time because it can be, you're not going there for a 2-day observing run, basically. Now there is a visitor center on Mauna Kea in Hawaii, but it only gets you halfway up the mountain because the summit is so high that they actually have astronomers stay at a dorm about halfway up the mountain, and then they watch you for altitude sickness to make sure that you can actually handle going observing all the way up the top. And if you can't, if your altitude sickness is too bad, they have somebody else take your data for you and give it to you. You don't necessarily get up there. But yeah, one of the first things you see when you go into an observatory usually is an oxygen tank.
Yeah, it makes sense. I was wondering about that because it was so high. So
Yeah.
thanks for adding that information. And then why do they call the day a telescope starts up first light?
So we call it first light because it is the first time that we're actually getting light from a celestial object to actually take data. So there's been all sorts of tests to make sure that the optics work, but we call it first light because think of it as opening the dome for the first time and letting the first starlight fall on it. So it's actually a very poetic term for what's basically, let's just use this telescope for the first time.
It's very poetic when you think that normally the names for telescopes are very large telescopes.
And don't get me started. I almost went and found some of the other ones with horrible names, but I thought I wouldn't be able to hold in the sarcasm. Not like I did, but
I,
yeah.
I like it. I think it's great. You know exactly what you get. I have a question here, and I think that would demand a longer discussion that might not be the forum here, but what do you think could be done to stop all the satellites?
Um, I don't know that I have a polite answer to that. The we and the unfortunate thing is that these were projects done by American companies that were given a go by American government agencies, and yet it's damaging the sky everywhere. Like I said, this is an image from Chile. And so I think there is something we need to say about who owns the sky. And right now we are saying billionaires own the sky, and I think that's about as polite as I can put it.
Fair enough. We'll leave it at that.
Keeping it all ages here, all ages friendly here.
Yes, no, I think that's good. That's a whole different, larger discussion.
Yes.
Interesting one for sure.
For the ethics group.
Yes, I think it
Yes.
would be very interesting because it's
Yes.
not like they don't have some, well, we'll leave it at
Yeah.
that.
Yeah.
We'll leave it at that.
Yes.
Why do satellites leave trails
Oh,
behind?
that's a great question. It's not, so what's happening there is that normally when we take photos nowadays, we're just really used to taking a snapshot, a real quick shot. But to observe the sky and get light from distant objects, we leave the camera shutter open for a long period of time. So what you're seeing when you see satellite trails, you can also see star trails for too. If you just leave the camera open and aimed at one place, satellites will just go by. And so what you're just seeing there is actually the movement and the number of satellites that went by during this one observation. That's what you're seeing.
And the next question is the damage that we saw to one of the telescopes where the cable snapped. How much does that affect the integrity of the telescope's observations right now?
So that was a big chunk, I think, out of Arecibo's 300, like what, 300 meters or so, or however big it is. I think it was about 100 feet across. I mean, it's a serious chunk of it. So I think most, if not all, observations are down right now, if I recall correctly. And we're getting into hurricane season.
Oh, yeah.
So there is some debate on whether or not they should start trying to fix it now or if they should wait for hurricane season to finish.
Yeah, that's a good thought to think that
Yeah.
through. Not bad. Interesting question since we talked about naming. So the next telescope that might be built is probably bigger than the extremely large telescope. What name do you think comes after extremely large
No,
telescope?
I think I'm trying to remember. There's one, I think it's Owl. I think there's one that starts with outrageously large.
All right.
I think it starts with that. And I think at that point I just tune it out, quite frankly.
It's a good question though, like
Very
where
good question.
where do you end? I think it was great.
Yes.
And then we have a more personal question for you, which I love. I always love to hear a little bit more about the personal side of our presenters. Were you inspired to go into science and astronomy by visiting observatory as a kid?
Thank you for that question. I have to actually say that question came from somebody I've known forever, but I probably haven't seen since high school. So hi. Um, so it's for me, I'm just a nerd. My interest in astronomy and science actually came from Star Trek as a kid. The idea that space exploration was just something people did. And so I thought we were out there and then found out later we weren't. But between that and the beautiful images that astronomers produce of the sky, I wanted to know what out there could be so beautiful. Like what made things so beautiful? Because nebulae and galaxies and Saturn and Jupiter and Pluto, they're all so gorgeous. They're all so beautiful, and it makes you want to understand them. Yeah. So
Like
so basically pretty pictures and science fiction is what got me interested.
exactly what did it for me.
Exactly.
Not enough to go professional, but my love for space definitely stems from that.
It's important to have that love when you're working in a science museum because the love that the people who work at the fleet have shows.
Thank you. I agree.
Yes, it does.
So we're going to end the evening with one more question.
Uh-huh.
Where did the high level of energy that produced the Big Bang come from?
That is a fantastic question. And if I could answer it for you, we could go pick up our Nobel Prize in Physics money together.
Yes, let's do.
Let's do that. But the idea is that the Big Bang model of the universe says that the universe behaves like it started with a bang. So if we say it started with a bang and make predictions from there, can we model the universe that we see today? The Big Bang model of the universe doesn't say what caused the bang, what came before the bang, or anything like that. So it's the whole idea, and I think that can be confusing sometimes because we can't even predict. Like the question is fantastic, like where'd that energy come from? But that energy would have come from before the creation of the universe, before the formation of the universe. And I can't use the laws of physics for this universe to predict what came before the universe. And I cannot construct a scientific hypothesis that I can test because I can't look before the universe. So
Yeah.
I can speculate, we can have fun with it, but we can't construct a valid scientific hypothesis and do an observation for what it came from. Great question, though. Wish I could answer
it. Maybe one day you'll win the Nobel Prize. Okay, I'm going to take
Possible.
one more question. Then we're really going to stop.
Okay.
But it's just so fun. So, who inspired you, other than Star Trek and the beautiful pictures, to do what you do now?
You know what's interesting about that is one of the hardest questions I ever get is every now and then I've been asked, so who is your hero? And you know how most people have answers for that? I don't. I don't have necessarily a person that gosh, this makes me sound cold and soulless, but I don't necessarily have like a person I look up to, or an idol, or someone I want to emulate, or someone I want to be like. Um, what I love about doing what I do, which is science education, whether it be my pre-med physics students at the community college or the all ages audiences here, what I love about doing this is that I feel like I get to put a little bit of good into the world, that I'm taking some knowledge that I have and I'm sharing it, that maybe I'm getting you excited about science, or even if you don't get excited, like if I'm not trying to get you to become an astronomer, but if you can go out in your everyday life and you can say that because you've been coming to the planetarium shows, you're like, science is a process and it has, we develop hypotheses, we test them, we do observations, and our ideas change, but that we can look out in the world with critical thinking and try to figure out what's going on. So even if you never become a scientist, but that you're actually more comfortable with science as something that is doable, then I feel very satisfied with what I do. Does that answer that question? And then in terms of like who, and then like the person who challenges me the most is myself. And I'll put it there.
And that's good. We all tend to be our greatest critics, right?
Yes. Yes, we are.
Sorry for all the questions. I should have asked you to take off the presentation for
Oh,
the recording, but there we go.
we always forget.
That's life. I want to thank Lisa, Dr. Wall. Thank you so much for giving us a wonderful presentation again this month for Sky Tonight. I love it. I always appreciate you giving us your time and your expertise. I want to thank everybody who joined us tonight for being here, for your love for astronomy, and for your support of the Fleet Science Center. It's wonderful. We love you all.
We miss you.
And I wanted to let you guys know your purchasing a ticket for the talk tonight does support the fleet, especially now that the building is closed. And we have a fantastic opportunity for you if you would like to support the fleet further. We have a matching grant going thanks to a generous donation from a donor. So if you donate to the fleet right now, we match your dollar once. So your money twice. You twice the bang for your buck, I guess is how you say it. It's kind of like a big bang for the fleet. So if
Nicely done.
Right? So if you would like to support the fleet, I think now is a great time to do it. And we thank you so much for joining us tonight. We sure hope we're going to see you next month on October 7th when we look at, I forgot again, dang it.
The life cycle of stars.
The life cycle of stars, exactly.
So
too many programs in my head.
Explosions and pretty pictures.
Well, that's much easier to remember, explosions and pretty pictures. I just have a lot of science programs. So sorry, Lisa, it's nothing about you.
No worries.
Again, thank you, everybody, and have a wonderful good night and a good week. Stay safe and healthy.
Stay safe.